So will I be able to interact with them, or they will just be like,
It'll be on chat.
they'll be on chat and I have to?
Because last time we did live interactions, but their bandwidths were not great, so it was like coming, going, coming,
Ah,
going. It was
okay.
disturbing for the other people also.
Sir, now we are in live. Okay, if you don't know,
Oh, okay.
in the screen share item, so you can start this.
Oh,
You can
okay.
start.
I can start the session. Okay.
Get him onto the video first, maybe. Yeah, but questions, just show him saying what is it, tell a hi and start the session.
Yeah.
Let him get onto the channel, say this one and then start. You know,
Okay.
already come, right?
Yeah. I guess. There seems to be a bit of a lag.
Yes, sir. Little delay will be.
Oh.
Now we are seeing this.
Ah, okay. Yeah, so I can they hear me now, or oh, okay. So welcome everybody. Sorry for the delay. I think we just ran into some very difficult technical issues. We had to move from one studio to another.
I'm not sure, because it's frozen. It's frozen because that Matroshka thing happened. Yeah.
No, it is fine.
So
Just screen will keep going inside it. These are.
so can we just get some confirmation that it's working now? It's Hey Bharat, can you be on live chat to see and
Just
yeah.
quickly log in.
Yeah.
Oh.
So Indian, we have what is the
I will do it. You can.
oh, this is also not calibrated. It should be calibrated. See, this is
See, try with the installer. Back on the canal will come.
Still connected to the
Pen will not work.
okay. Pen will not work. Then so it's oh, so they are able to. Are they able to see?
Yeah.
Okay.
Now you can see here itself. Nobody is going. I mean, they will see you only. Sir.
Okay, I see. Okay. So they'll be able to see and hear me.
Yes, yes.
Okay.
Yeah, you can have this. You can see in from there itself.
I see. Oh, okay. Oh, okay. So, yeah, again, very sorry for all the confusion. So today's session is, I don't have anything planned to lecture on. I intend this to be a session to address doubts and a session to just interact with you and find out how the course is going, and if there's something we can do to help, and essentially give you a chance to talk to me and tell me what if there's anything that needs clarification, if there's anything that needs a little bit better explanation or anything like that. So yeah, I'd love to see. Love to see your comments and your questions. So if you have any questions, and I think in the, for example, I saw one technical question that was posed, uh, earlier in the spreadsheet about linearity of expectation. So if you have any such similar questions, I would like to try and address them now. Um, So let me get started on addressing the question of the linearity of expectation. Unfortunately, I don't have a way to. This actually would require a little bit of maybe a board or something to write on to really explain what I'm the linearity of expectation. But in some sense, what is happening is, let's take the simple case where there are two variables, x and y, and two random variables. And let's say you want to, what is linearity of expectation? It says that the expectation of x plus y is the expectation of x plus the expectation of y. So you can, if you have a random variable that's in some sense a combination of two random, additive combination of two random variables, x. So x plus y itself is a random variable if you think about it. And it's now a combination of two random variables, x and y. Then essentially you can apply the expectation operator on the two individual random variables, add them up, and you get the total expectation, right? Why is that the case? So and the important thing to keep in mind is that it doesn't depend on. It is not affected by the dependencies between x and y, and this can be pretty counterintuitive. It's also very powerful. We exploit this feature quite extensively, but on the other hand, I think the question was aimed at asking why is it the case, and intuitively it goes back to the fact that these two random variables x and y are coming from this. Let's say they're coming from the same sample space, and the random variables are essentially just reacting to the underlying experiment. And if you are an observer just looking at x or just looking at y, you will not see any influence of one versus the other. And I know this is a bit of hand waving, but if you work through the derivation, the proof that e of x plus y is equal to e of x plus e of y, you will sort of see that the probability kind of affects both random variables in the same way. And that's why you're able to apply the probability in the same way across both random variables in some sense, and therefore linearity of expectation holds. Unfortunately, the current technical situation does not allow me to kind of showcase this, but if one thing I would do is I'll just keep a note of this and try to send an email, an announcement, if you will, just clarifying the technical details that I'm not able to explain at this moment. Okay. So that's one. I think that's one issue that was raised, and is there any other questions, comments? Karthik, do you have any question? Question number 11 of assignment 3. Yeah, so let me, I'm just going to get some help from my TAs to find out what question that is, and I'll try to address the question. That's question number 11. So the TAs are just going to give me the question in a minute, and so that I'll know what the question is about, and I'll try to address that. Oh, is it Karthik? Is it just to be clear? Are you asking about question 11 or 12, or are they somehow combined? Are they? Okay, yeah. Let's consider an experiment in which a fair coin is tossed n times. Okay. Okay. All right. We have n random bits. Yeah. Yeah, I need the question. I need the question because otherwise I won't be. I don't know what the question is. Let's consider an experiment in which a fair coin is tossed n times to obtain n random bits. Consider m equal to n, choose two pairs of these bits in some order. Okay. Let yi be 1 if the exclusive or of the ith pair of bits. Be the excellent, okay. Let y be the summation of the yi's. Be the number of yi that equal to 1. What is the probability that any given yi is 0? I think the question that Karthik had is on the next part. Yeah, I think so, because the first, I think basically it is question number 12. Let's consider. Let's show there are n choose two pairs. Okay. Yeah, 12 and 13. Okay, so let's see. In the experiment described in 11, are any two given random variables yi and yj guaranteed to always be independent? Okay, so the 12th question is asking, are there random variables yi and yj that are guaranteed to be independent? Yeah, so sorry, it took us a while to get to the question, but so I have the question now. So let's look at maybe let's ask, when does dependency show up and when does it not show up? Well, when let's say now you have two random variables yi and yj. They're exclusive. I mean, they're basically exclusive ORs of to the original independent bits, right? So sorry, we're losing the question. Okay, in the experiment described in 11, are any two given random variables, yi and yj, guaranteed to always be independent? So, so this question is asking, are there pairs of random variables yi and yj that can be independent? Okay, so now dependencies. Let's look at any pair yi and yj. Now, if you are focusing on yi and yj alone, what is the these two random variables? Can they be dependent, or will they be independent? That's the question, right? So let's think about this for a second. If yi and yj don't share any of the original bits, because yi and yj are essentially the exclusive ORs of original bits, right? So if they don't share a common bit, they are clearly independent. Okay, so that itself in some sense answers the question here, because it just says, are any two given random variables yi and yj guaranteed to always be independent? As long as yi and yj do not share a bit, it's clear that they are independent. Okay? So now I have printouts. So let's look at the case where they do share a bit. Okay, if they share a bit also, if you think about it, they are going to be independent. If you just consider two random variables, yi and yj. So they when I say they share a bit, that means let's say yi is the exclusive OR of bits, say 3 and 5, and yj is, let's say, the exclusive OR of bits 5 and 7. So they share the fifth bit. Okay, so now let's what we have to argue for independence is, let's pick two values of for yi. Let's say yi and yj. So they have to be independent for all combinations of values they can take: 0 0 0 1 1. Yeah, that's right. So that's the one, 1 0 1 1 and so on. Okay, so they for every pair of possible values that yi and yj can take, we need to argue that the probability of yi taking its assigned value and yj taking its assigned value, the probabilities of the combined event is the product of the individual probabilities, right? So what is the let's just make sure we have a sense of what the individual probabilities are. It's probability of yi equal to, let's say, any value, say 0, is going to be a half. Okay, because you're taking the exclusive OR. So there are two out of the 4 possibilities for the exclusive OR. 2 of them will lead to a 1. So probability of yi equal to 0 will be a half. Probability of, let's say, yj, we fix the value as 1. Okay, probability of yj equal to 1 will also be a half. Okay, so let's look at the now the probability that yi equal to half and yj intersected with yj equal to a half. Okay, so we're combining the two events and asking what is the probability of that. Okay, and so this is basically the event that yi takes the value 0 and yj takes the value 0. Okay, so okay, so now what is that? So I don't have I need to write something. Yeah. So I'm just trying to work out the cases. Why I equal to 0 because so it's and so yi will be 0 in for this one yi will be 0 and yj will be 1 in cases basically this one yeah yeah, so this is going to be 1, 2 out of the 8 cases. Yeah, so sorry I was not able to show my working, but I just worked out a truth table. I wonder if I can just show it this way and I don't know, is it visible?
There's a lag.
There's a lag, right? Yeah, sorry, we were completely caught off guard without our usual equipment. So, so if maybe they can't see it. So what I've shown is remember we decided that yi is the exclusive OR of the third and the fifth bit, and yj is the exclusive OR of the fifth and the seventh bit, and they have this fifth bit in common. So what I have here is all the possibilities, and what I've circled is the event where yi is 0 and yj is 1. Okay, and you will see that it's 2 out of the total 8 possibilities. So the probability is going to be a fourth. And if you take the individual probabilities, probability yi equal to 0, that's a half. Probability yj equal to 1, that's also a half. So the product of it is also a fourth. And so that's how you can establish that they are pairwise independent. So if you take yi and yj, they're going to be independent. Now dependencies will start creeping up if you include a third variable in say yk into the picture. That is correct. So choosing the pairs is in itself, I think, yeah, if it is pairs, they're independent. That's, yeah, if that's what Sri is talking about. Yeah. Okay. So did this address the question, Karthik and Sri? So I'm just waiting for a response to see whether this explanation made sense. Are they convinced? Okay, good. So happy to know that. Yeah. So do you guys have any other questions? Yeah, please go ahead and ask. Okay, good, good. I'm happy, Karthik, that the question got addressed. Any other questions? Anybody? Question 20, assignment 3. So let me take a look at that. Okay. Alice and Bob play chess often. Alice wins any given game they play with probability 0.6. They both decide to play n games in total. Use the following Chernoff bound to bound the probability that Alice loses more than half the games they play. So if you okay, so let's look at this question carefully. Now, Alice is a better player than Bob. So Alice is going to win. Her probability of winning is 0.6. So she's a better player. So in some sense, the surprising thing would be if after they play n games, somehow Alice has Alice loses more than half the game. So that would be a surprising outcome, right? And so we want to ask, what is the probability of such a surprising outcome happening, right? And for that, this Chernoff bounds is a very useful technique. Okay, so now what we do is we look at these games, each individual games, as a Bernoulli trial. Okay, we say that so we ask, what is the probability with which Alice will lose a game? Okay, that's going to be 0.4. Okay, so you expect her to lose about a fourth, 0.4 times n number of games. Okay, but then the surprise event or the bad event is when she loses more than 0.5 times n number of games. Okay, so now you can apply Chernoff bound. So let's unfortunately I don't have anything to write. The technology doesn't allow that, but we can. It is not very difficult to see. You can assign you can create a random variable xi to be 1 if Alice loses a game and 0 if she wins the game. Okay, because we are concerned about her losing more than 50% of the games, right? So the 1 for us is when she loses. Okay, so now that's xi for the ith game. So our capital X will be the summation of all the xi's. Okay, and what is the expectation of this capital X going to be? It's going to be 0.4n, because you expect her to win about 40% of the games. All right. So then the other parameter you will need is that delta to apply this particular Chernoff bound that is given. Okay, so now what is this delta? So that needs to be worked out, right? So is there a pen here? So we want, I'll just do a quick calculation here and show it to you. We want 1 plus delta times n to be equal to 1 plus times n times 0.4n to be equal to 0.5. So n will cancel out. 1 plus delta I delta equal to. Okay, So I've done a very quick calculation. I want my remember I want to ask what is the probability that more than 50% of the games are lost by Alice. So that's this 0.5n. Okay, um, and so this 1 plus and that's this 50.5n, and on the left hand side, I'm just trying to work out the value of delta. So what I have in the formula, in the Chernoff bound formula, is 1 plus delta times 0.4 times n. Okay, and I want to get this that part of the formula to equal 0.5n. So all I'm doing now is solving for delta, and then delta will work out to be 1/4. Okay, so now you plug that into the Chernoff bound formula, and that formula is already given in the question. And when you plug that into the formula, it's right here. You will get e to the it's too small for you to see, I'm sure. It's e to the minus mu delta squared by 3. Okay, and you know the mu value, which is 0.4n. Delta is 1/4, so that's so delta squared will be. So let me write that out. E to the minus 0.4n times 1 over 1/4 squared, so that's 1 over 8 times 1 over 3. And let's see, so 0.4, so that I think is, you can also write this 0.4 as 4 or 4 over 10, right, or 2 over 5. So that's e to the minus n by 2n over 5 times 8 times 3. So the 2 cancels with 4. That's equal to e to the minus n by 5 into 4 into 3. Okay, did I 5 into 4 is, did we just miss, did I make a mistake here? So is the delta 1 over 4?
Yeah, delta is 1 over
4. So, delta squared, sorry. So this is, yeah. So then this will be not an 8, it will be a 16 divided, okay. So,
So it should be 120 basically.
yeah. So e to the minus n 2n by 5 into 16 into 3. 5 16s are 80. 80 times 3 is 240. That's equal to e to the minus n by. Okay. Can this is this visible at all, or should I write? Oh, this might be better, but maybe for the next question. Please refer the good book for this course. What is the good book? Yeah.
Do you want me to write it here?
No,
Field is gone. Someone's asking for a good book.
yeah, I'm trying to understand what the good book is. Are they?
No, it's not live. The video got done. Should I just type in Mitchell Mata?
There's no writing part,
I desperately need something to write.
Mohan and the
It didn't calibrate for some reason.
ಇವತ್ತು எழுதியிருந்தாரு பரசுராமன் சுவாமி why don't you put that on?
அவங்க மாற்றிடுவோம் லைவ் ஸ்டார்ட் பண்ணி வச்சுருக்கு அதுலேருந்து அதை லாகின் பண்ண முடியாது ஒரு தடவை தான் லாகின் பண்ண முடியும்
இதுலேருந்து login பண்ணிடுறது.
அந்த சாஃப்ட்வேரில் ஒரு தடவை தான் லாகின் பண்ண முடியும், ஒரு மிஷினில் தான், 2 மிஷினில் லாகின் பண்ண முடியும்.
Then what are we doing with the tablet at all? Okay, you finished that.
இல்லை ஸ்ட்ரீமிங் போயிட்டு தான் இருக்குது சார்.
Oh. Oh, I'm back on. Okay. So, guys, I think there was a little bit of a break. Again, sorry about that. Oops, what happened to the show chat? Someone was referring to. Yeah. I see. Okay, so no, I think so one quick question for the viewers. I try to write things and show it on a piece of paper. It's not clear to me whether you are able to see it. So if you can type and let me know whether you were able to see it, whether my explanation was was making sense, that would be helpful. We're just caught off guard with some technical issues, so we're not in a studio. We're kind of trying to make do with the situation that we have. Oh, thanks to my TA, we have a better explanation. I mean, hopefully this is more clear to you. So this is 1 plus delta times 0.4n, by the way. This is and that should be equal to 50% of n. Okay, so when you solve for delta, you get 1/4. Okay, and that we are going to plug into the Chernoff bound formula, at least on the right hand side. We will have e to the minus mu delta squared by 3. Mu is 0.4n. Delta square is 1 over 16 because delta is 1/4. And this 1 over 3 here is the 1 over 3. And when you solve, it's e to the minus n by 120. Okay. Yeah, I think that might not be a bad idea.
So this will address the other question.
Okay. So, guys, sorry to keep you waiting. It's 6:15 now, and I think we should probably call it a day today. And once again, we apologize for the complications. And one way we could see if we can avoid, we can sort of make it up to you is if there is still a need, if we still haven't addressed your questions, we'll be happy to have one more session. Hopefully we will not have studio issues at that time, and if that's so we should be able to get this done. Okay, so if you feel that another session is required, and I'll post an announcement to this effect, we'll try to have one more session, so you're also free to just ask questions in general on Discord server, or that would be probably the most appropriate place to drop questions. We will definitely try to address your concerns. Okay, so thank you very much. Thank you very much for the patience. We'll end now and catch up some other time. Okay, thank you. Bye.